Hi, my name is Jordan Johnson, and I'm a third-year biochemistry major. Today I'm going to show you how to solve practice problem number 4 from chapter 3.3 in the General Chemistry workbook. I highly encourage you to pause the video now and solve the problem yourself, then go through the video if you're stuck. So the question is, how much of a 3.5 molar solution of sodium hydroxide should you use to make 200 milliliters of a 1.5 molar sodium hydroxide solution? Describe how you would do this solution. So let's start with what we know. We know that our initial concentration is 3.5 molar. We know that the concentration that we want to have is 1.5 molar. And we know that the final volume that we want is 200 milliliters. What we want to find out is the volume that we would take from that initial solution in order to get our final solution. So how would we go about solving this? Well, the way I labeled these things kind of gives us a hint as how we would normally do this. So we have an equation to help us figure out how to find our initial volume, and that is the dilution equation, which is equal to M1, V1 is equal to M2, V2, which basically tells us that the concentration of our initial solution times the volume of our initial solution is going to be equal to the molarity of our final solution times the volume of our final solution. So let's set up this equation so that it works for our particular question. In order to do this, we can just move the M1 over here by dividing. So we get V1 is equal to M2 times V2 divided by M1. And then we can just plug in our numbers that we already determined earlier on. So for M2, we have 1.5 molar. For V2, we have 200 milliliters. For M1, we have 3.5 molar. And when you do the math, you'll get 85.71 milliliters, which is approximately 86 milliliters. So we got a number, but what exactly does this number mean, that V1 is equal to 86 milliliters? So basically what this means is that, say, we have a container of our 3.5 molar solution, and we want to set up our container over here with a 1.5 molar solution. What this V1 essentially means is that into our second container, we're putting 86 milliliters of the 3.5 molar solution. So you might be wondering, okay, but our V2 was 200 milliliters. So how do we get there from our initial volume of 86 milliliters? So how we do this is essentially by diluting our 3.5 molar solution. Now, how we usually do this is with water, but there are some cases where you could use organic solvents or some sort of buffer to dilute it. So how we get the volume that we need to add of water to dilute it is pretty simple. We just do 200 minus 86. In this case, that'll give us 114 milliliters of deionized water. So by talking through this question, we've pretty much figured out how to answer the second question, which is how would you prepare this? We'd prepare this by getting a beaker of 250 milliliters or higher so that our solution doesn't overflow, and then into that beaker put 86 milliliters of 3.5 molar sodium hydroxide, 114 milliliters of deionized water, and stir that up. So now we have 200 milliliters of a 1.5 molar sodium hydroxide solution.